My name is Milo Simpson, and this is my presentation on acid rain, its causes, effects, and solutions towards a cleaner future. So, why is this important? Acid rain is very harmful to wildlife and a lot of ecosystems. And us humans are the main contributors, so it's important to know how we contribute and how we can slow down its progress. It also contaminates fresh water sources, making them undrinkable or uninhabitable to wildlife living there. And it can be blown across regions, so it doesn't only affect the regions that it formulates in, it can be blown across to many other places as well. So just some background information. pH scale ranges all the way from 0, which is the most acidic, which would be battery acid, all the way down to 14, which would be lye, which is very alkaline, the least acidic. Normal rain sits at a pH of about 5.6. So as you can see right here, here's the normal range for precipitation between 5 and about 6.5. And then normal range of stream water is also around that same range. But the pH level of acid rain is between about 4.4 and 4.2, which is, you can see right here, gives a little bit of a broader one, but it's still very, very acidic. And very generally, acid rain forms when fossil fuel emissions combine with water in the atmosphere and then fall back down out of the atmosphere. So historical development. The term acid rain was first used in 1852, by a Scottish chemist named Robert Angus Smith. He was studying the water chemistry around industrial cities in Scotland and England, and noticed that they were becoming a lot more acidic. But he was ignored at first. No one wanted to listen to him. Everyone didn't believe what he was saying to be true or important. But then in 1967, Svante Odin was a Swedish chemist, and he associated the decreasing pH levels in Europe with the increasing amount of fossil fuel emissions in those areas. And it affected the chemistry of surface water and rainwater. It was recognized as a regional issue in North America and Western Europe between the 60s and 70s. It is now officially recognized as a global issue. It has been reduced in a lot of areas, but it still affects major agricultural and industrial areas. So as you can see over here, a lot of industrial places in the Northeast have very acidic rainwater and pH values with their water. There's a lot of industrial plants and everything going on there, so a lot more fossil fuel emissions. So the chemistry of acid rain, sulfur dioxide and nitrous oxides are emitted into the atmosphere. Sulfate and nitrate ions are the main contributors. So as you can see in this diagram over here, you have both sulfate going in and making it a lot more acidic in that rain cloud. And they are primarily released from fossil fuels, so things like factories and cars are big contributors. There is a very, very small amount of sulfur dioxide emissions that occur naturally from things like volcanic eruptions, but that is a very, very small percentage of those emissions. So there are two acids that contribute to acid rain. I'm going to start with nitric acid. So at very high temperatures, usually from combustion engines or lightning strikes, nitrogen and oxygen react to form nitric oxide right here. Nitric oxide then very quickly reacts with oxygen to form nitrogen dioxide. And that's actually what gives smog its brown color. So if you remember in one of the first labs we did when we were burning off that chemical reaction and it was producing that brown fume, that's actually what that was. And then nitric oxide dissolves in water to form a 1-to-1 ratio of nitrous acid and nitric acid. And then eventually that nitrous acid is oxidized and all of it turns into nitric acid. And this is your final chemical equation here at the bottom, all ending with nitric acid. And then with sulfuric acid, a lot of sulfur dioxide is released in the atmosphere when smelting precious metals like zinc and trying to extract those. So a lot of sulfur dioxide is released into the atmosphere. It then dissolves in the water in the atmosphere to give sulfurous acid, and then that is oxidized as well to give you sulfuric acid. And then here's a little diagram, ball and stick diagram of sulfuric acid. So acids are deposited one of two ways, wet or dry deposition. Wet deposition is what most commonly thought of. That can come in the form of rain, snow, sleet, hail, any actual physical precipitation, just actually physically falling out of the atmosphere. And this can be very harmful to wildlife. As you can see, this is a forest that was affected by a lot of acid rain and wet depositions. So a good example of this is that plants are very sensitive to aluminum in the soil, in their groundwater especially. And normally, aluminum hydroxide cannot dissolve in normal water with its pH value, but when there is a lot of acid rain, wet deposits, it is actually able to dissolve in the more acidic water, resulting in a high concentration of aluminum 3+ ions, which do a lot of harm to these forests, as you can see. And there's that chemical equation, so you have to use aluminum hydroxide with the hydrogen in the water. It turns into a lot of aluminum 3+ ions. Dry depositions are when the acidic particles in the atmosphere are being placed and depositing directly onto surfaces. This can do a lot of harm to things like buildings and statues, as you can see right here. This statue has half of his face just burned off from the acidic deposits on it. And the thing that's really harmful about dry deposits is on the next rain, all those will be washed off and they can run across the ground, affecting a lot of the wildlife. They can run into bodies of water, changing the chemistry of bodies of water, and affecting plants a lot as well. And the real difference between whether an area is going to experience dry or wet deposition really just depends on how much precipitation that area gets. The more precipitation it has, the more it's going to be wet deposition, less it's going to be more dry deposition. The best example would be that a desert is going to have a lot more dry deposition than a rainforest would, because there's a lot more precipitation in the rainforest. So what role do experts play? Lawmakers are working to create limitations on how much of these emissions can be released, such as the 1998 Clean Air Act, which is working to reduce emissions, and the EPA actually caps the amount of sulfur dioxide that power plants are allowed to release into the atmosphere. They also use a process of washing coal, which according to the EPA is where they wash a lot of sedatives and impurities in the coal, which will then reduce the amount that is burned off from the emissions. And they also use sulfur dioxide scrubbers, which when they're burned in the chimneys, they release absorbents, as you can see right here. Those react with water, the sulfur dioxide, and then sulfur dioxide usually forms a solid byproduct. It's usually calcium sulfate down here, so it's not being released as much into the atmosphere. So societal impacts, there are no real societal impacts. You could make the argument that it's pushing governments and to create policies and enforce them to reduce the amount of emissions that industries are allowed to release. And it forces them to look for cleaner energy sources. Negative impacts, it changes water chemistry, which doesn't only affect the organisms living in those bodies of water, it affects people who use them as their primary drinking water source. It also just affects organisms that have aquatic organisms primarily in their diet. If that population goes down, they're not going to be able to find food. It causes a higher rate of tree mortality and alters soil chemistry, making it more difficult for things to grow in those areas. In conclusion, sulfur dioxide and nitrous oxides are the main contributors primarily released by humans. They're not always precipitated. You can't always just directly see it falling out. You don't always know it's there. They cause major harm to all ecosystems. And industries are really the main contributor to this problem. And governments right now are really working to try and find cleaner solutions and make more policies to try and slow this down. And then these are the sources that I used